Today, we're diving into a hidden problem in car manufacturing and the incredible, high-tech solution that fixes it. We're going to look at research from the Journal of Manufacturing Processes to see how a simple beam of light could make your next car last years and years longer.
First off, take a close look at this. All that gunk, that's what's left behind when a car's frame is welded together. Now, it's not just ugly residue, it's a weakness built right into the structure of the car. And for the auto industry, believe me, cleaning it up has been a massive headache.
So, to really understand why this is such a big deal, we need to uncover welding's dirty little secret.
It all starts with the steel, and this isn't just any old metal. It's a special, high-strength alloy called SPFH590. This stuff is the key to building car frames and wheels that are both incredibly strong and surprisingly lightweight, which is exactly what you want for modern, efficient cars.
So, how is this mess even created? Well, it all happens during arc welding. You've got this electric arc that generates an insane amount of heat to join the steel parts. But all that heat makes the steel react with oxygen in the air, and that reaction creates three things you really don't want: a thin discoloration called heat tint, an oxide layer that basically invites rust to the party, and those chunky deposits we saw, which are called slag.
And here's the crucial point. This is not just a cosmetic problem. These byproducts are the enemy of longevity. They actively sabotage the steel's natural ability to resist rust, and they make it almost impossible for paint to stick properly. So leaving this stuff on a car frame is basically like building in a fatal flaw that guarantees the vehicle will have a shorter life.
Okay, so if this gunk is so bad, you're probably thinking, just clean it off, right? Well, it's not that simple, and that brings us to the trouble with tidying up. For years, manufacturers were kind of stuck between a rock and a hard place. On one hand, you've got mechanical methods, like wire brushing, but that can literally scratch and damage the very surface you're trying to protect. On the other hand, there's chemical cleaning with some pretty harsh solvents. The problem there, it's toxic, it's dangerous for workers, and it's an environmental nightmare. But what if there was a third way, something powerful, precise, and perfectly clean? This is where the light beam solution comes into play. And here it is, the hero of our story, a high-power, nanosecond pulsed fiber laser. This is a completely different way of thinking. It's a non-contact process, which means zero surface damage. And because it's literally just using light, it's an incredibly eco-friendly method that produces zero secondary waste. So how in the world does a beam of light clean solid metal? Well, it's this really clever two-pronged attack. For the thin stuff, like the oxide and heat tint, the laser uses something called thermal ablation. Just think of it like instantly vaporizing the gunk right off the surface. But for that thick, chunky slag, it does something even cooler: plasma-induced thermal stress. The laser creates a tiny plasma explosion that generates a micro shockwave, shattering the slag and blasting it away. It's awesome. Now, this all sounds amazing in theory, but does it actually work in the real world? That's exactly what these researchers set out to prove. Let's see how they put this laser to the test. And this just says it all. On top, you've got that messy weld before cleaning. And on the bottom, that same surface after being hit with a 160-watt laser. The difference is just night and day. The researchers actually tested a range of power levels and found that 160 watts was the absolute sweet spot for a perfect clean. We can actually measure the clean by looking at the oxygen content. Remember that oxide layer is what kicks off the rusting process. Before cleaning, the surface was over 25% oxygen. After the laser treatment, that plummeted to under 5%. That is a huge drop, and it's a crystal clear sign that the potential for rust has been knocked way, way down. And what about the slag? The results here are honestly even more impressive. At 160 watts, the laser completely annihilated 100% of the slag in the center of the weld and still got rid of 80% from the trickier edges. And you can see here the main ingredients of slag, silicon and manganese, have practically vanished.
But here's the real million-dollar question. Does a cleaner surface actually mean a longer-lasting car part? To find out, the scientists put this steel through the ultimate endurance challenge, the 15-year test. Now, obviously, they didn't just wait around for 15 years. They used what's called a cyclic corrosion test, or CCT. You can basically think of it as a time machine for rust. This machine blasts the steel with cycles of salt spray, crazy high humidity, and drying heat, simulating years and years of harsh road conditions in just a few weeks. And the results are absolutely stunning.
Just look at this. After 95 cycles inside that corrosion chamber, the sample that was not laser cleaned is a complete rusty mess. But the laser clean sample? It looks almost pristine. The visual evidence here is just undeniable.
So what does this all mean in the real world? It means the laser-cleaned steel officially passed the industry's 15-year corrosion durability standard. This technology doesn't just clean a surface, it fundamentally extends the life of a critical part of the car. This diagram shows us exactly why this works so well. See, when you paint over a dirty weld, these tiny little gaps are left between the slag and the steel. Corrosive stuff like road salt seeps into those gaps and just starts eating away at the steel from underneath the paint. By the time you actually see the rust bubble up, the damage is already really bad. Laser cleaning gets rid of those gaps completely, creating a perfect seal against corrosion. So what we have here is a powerful, precise solution for a problem that affects millions of cars. And it really makes you wonder, if a focused beam of light can stop rust before it even starts, what's the next impossible task that it's going to solve?